Hello all and welcome back. When you build your Excel applications, whether it is for your clients or for your teams, you often include an about form to show whether version information, credits, or sometimes even instructions. Most of the about forms are very basic. Little bit of text, a static image, and an OK button. In this video, I'm going to show you how to make the same about form into a tiny animated world inside your Excel. I'll walk you through 5 fully animated forms, each one inspired by the 5 elements of nature. There is an ether form with a glowing star field drifting in deep space. An air form with a bright blue sky filled with gently drifting clouds. An earth form with rolling green hills and moving clouds, a fire form with living flames, and a water form with soft ripples spreading across the surface. Everything that you see here is created at runtime using GDI and VBA. No images, no GIFs. And each form is plug and play, ready to be used in your Excel application. And in the end, there's also a bonus about form. So if you want your Excel tools to feel like real polished software rather than ordinary worksheets, then keep watching. So let's begin with the first element. I'm already inside the Visual Basic editor. If you're not sure what this window is or how to open it, I recommend watching my earlier video, Visual Basic Editor and Introduction, and then coming back here. For this demo, let us look at the Aether About Form. In the project window on the left, you will see a form named FRM About Aether. I will double-click that to open it in the design view. You can see the form here on the screen. Think of this as a template for your About box. The animated Aether effect will appear only in the bottom part of this form. The top area is where we will show all the information about the application. Let us quickly walk through the components. At the top, we have a big label that says something like Excel app name. This is meant to be the title of your application. You can change this text to match your own project. Just below that, there is a smaller label for the version. Again, you can type your actual version number here. For example, version 1.3.0 or whatever you use. Next, we have a block of text that looks like a copyright line. Something like @current year, your company name, all rights reserved. You can change the year, your company name, or even remove this completely if you do not need it. Below that, there is another label with a line that says other text you want to show here. This is just a placeholder. You can use this area for a short description, a website link, author name, or support contact details. Then we have one small line that says press escape to close me. This is simply a user hint so that people know that they can press escape to dismiss the about form. You can keep this message or replace it with your own wording. Finally, we have a thin separator line. Everything above this line is static text and controls. Everything below this line will be painted using GDI at runtime. This is nothing else but a frame control. So if I select this, you can see it's a frame control. This will be placed dynamically at runtime below press escape to close me. Okay, very important. You are free to change the text of all these labels, change fonts or slightly move them around. The only thing you must keep in mind is that all your labels should stay in the top half of the form. Roughly speaking, keep your content about the 50% height of the form, so that the animated band at the bottom has enough space to breathe and does not overlap with your text. So, this is the overall design of the Aether About form. Top half is clean information about the app, bottom part is reserved for the animated effect. And before we jump into the code, one quick heads up. If you enjoy seeing how things work under the hood, stay with me for the walkthrough. If you're not interested in the code details, feel free to skip ahead to the demo where we run the form. Okay, now that the layout is clear, let us look at how the animation works behind the scenes. I will double click on an empty area on the form to open the code window, and we'll walk through the Aether code step by step. Let me scroll to the top. Okay, let us walk through what this Aether form is doing. At a high level, this form is drawing a glowing space band at the bottom of the window, with little stars gently drifting and pulsing. All of that is generated live at runtime using pixels and not images. So we will break it into 4 ideas. First, what settings and types we need. Second, how we grab the window and make it borderless. Third, how we build the Aether band and stars. And finally, fourth, how the animation loop keeps everything moving. Okay, let's start with the settings at the top. Right at the top, you will see 2 constants, Aether height ratio and frame above Aether gap. Aether height ratio controls how tall the Aether band is. I've kept it at 0.4, which means 40% of the form height. If you ever want a thinner band, you can reduce this value. If you want the band to take more space, you can increase it. Frame above Aether gap is simply the vertical gap between the Aether band and the frame that contains your about text. We are using that so the text frame sits neatly above the glowing band, not touching it. Next, we have few data types. Rect is a simple structure that window uses to tell us the size of a window. We will use it to ask Windows, what is the exact client width and height of this user form in pixels? Bitmap info header and bitmap info looks scary, but you can think of them as a description of a pixel buffer. We are going to draw into an array of pixels and then ask GDI to copy those pixels to the screen. These types tell Windows how big the image is, how many bits per pixel, and so on. Star is our own small type. Each star has an X and Y position, a radius for how big it looks, a speed Y to control how fast it drifts vertically, and an alpha, which is like brightness or transparency. So every little dot you see on the band is 1 star value in an array. Then we have all the API declarations. You do not need to memorize these. The main idea is find window helps us get the real window handle for this user form. Get client rect gives us the pixel size of that window. Get DC and release DC give us a drawing surface to paint on. Stretch DI bits takes our pixel array and throws it onto the screen. Sleep just pauses a bit between frames so the animation is smooth. These 3, get window long PTR, set window long PTR, and set window pause, are used to remove the normal user form frame and turn it into a nice borderless window. If you are a beginner, just remember one thing. These declarations are the bridge between VBA and Windows drawing system. Then you will see constants here. For example, DIB RGB colors, SRC copy, and star count. Star count is the number of stars that we want to animate. If you increase this number, you will get more stars. But at some point, it will also be heavier to draw. These 4 constants are related to window styles. They help us tell Windows, make this form behave like a pop-up, not like a standard dialog. Similarly, we have other variables. Now let's look at the helper function DIB color. This takes 3 values, red, green and blue, and packs them into a single long that represents a 32-bit pixel in memory. Internally, we are using an array of longs, not an array of RGB types, so this function does the packing for us. You can think of it as build 1 pixel from 3 color channels. Next, we have the make borderless procedure. The idea here is simple. By default, a user form has a caption bar and a window frame. For this kind of visual effect, we do not want any of that. We want a clean borderless window. Find window looks for a window class called ThunderDFrame with the same caption as our form. That is how we get the actual underlying window. Once we have it, we call setWindowLongPTR to change its style flags so that it behaves like a pop-up and is visible. Then we call setWindowPause with the SWP frame changed flag so that window reapplies the new style. We do not move or resize the window here. We just change how it looks. Now the most important part. Init Ether. This is where we set up the band and create the star field. First we get the handle using find window. Without this handle, nothing else can draw. Then get client rect gives us the width and the height in pixels. We then compute ether W as the full width of the form and ether H as a fraction of the form height using ether height ratio. So if the form is 400 pixels tall and the ratio is 0.4, the band will be around 160 pixels tall. We then allocate two arrays, base IMG and frame IMG, each big enough to hold one color per pixel for that band. After that, we fill BMI.BMI header so that stretch.di bits understands what kind of bitmap we are giving it. The key points here are width and height of the band, 32 bits per pixel, negative height to say that the first row in memory is the top row on the screen. Then we define our gradient colors. We have a R top, G top, B top color for the top of the band and a R bot, G bot, B bot for the bottom. The band is basically dark blue at the top, slightly brighter towards the bottom. On top of that, we use band center and band width to create a soft glowing strip in the middle. These lines are using a kind of Gaussian curve to make that glow. So, for every row Y, we compute T, which is how far down the band we are. We then calculate a blended color between top and bottom, add some extra brightness using globe, clamp the values between 0 and 255, and then write the same color into every pixel along that row. That gives us a nice vertical space gradient with a slightly brighter band in the middle. Once the background is ready, we create the stars. Here we redeem the stars array to star count, and for each star we randomly choose a starting X and Y inside the band, a radius between roughly 1 and 2.7, a vertical speed between 0.2 and 0.7, and an initial alpha between about 0.25 and 0.85. This randomness makes the field feel more natural and not too regular. Finally, we set initialize to true so that we know this setup is already done. Now the animation part. That is taken care of in this procedure, which is step stars. The concept is every frame, every star moves down a bit and its brightness gently pulses. Glow phase is a global phase value that increases slightly each frame and wraps around once it goes beyond roughly 2 pi. Then for each star, we copy it into a local variable s. We add s.speedy to its y position so it slowly drifts downward. If it goes off the bottom, we wrap it back to just above the top and give it a new random x. This is the line where the pulsing is handled. Each star gets a slightly different phase based on its index, so they are not all breathing in sync. Then we take the original random alpha and mix it with this pulse value to get a new S alpha. Finally, we write S back into the stars array. Let's move on. This procedure is build frame. It's pretty straightforward. First, we copy the whole base IMG into frame IMG. That gives us a fresh gradient with no stars. Then we loop through all stars and call draw star for each one, which draws the glowing disk into the frame buffer. So, at the end of build frame, frame IMG contains the current background plus all stars. Now, let's look at draw star procedure. This is where the soft circular glow is rendered. We do not want to loop over the entire band for each star. That would be slow. So first, we compute a bounding box around the star using its radius. That gives us min x, min y, max y. We clamp this bounding box so it stays inside the band. Then we loop over the small rectangle. For each pixel, we compute how far it is from the star center in terms of radius. If D2 is less than or equal to 1, the pixel is inside the circle. For those pixels, we calculate a local alpha, which fades from the center towards the edge. We then read the background color as a pixel, add some white light on top scaled by local alpha, clamp the result between 0 and 255, and finally write back the blended color to frame IMG. This gives you a soft, round, glowing spot for each star instead of a harsh block. Let's check out the next procedure. Blit frame is responsible for showing the band on screen. We first calculate dest y, which is the vertical position from where the band should start. Since the band is at the bottom, we take form h multiplied by 1 minus ether height ratio. Then we call stretch di bits, giving it the device context, the destination rectangle, the source pixel array, and the bitmap info. So one call to stretch di bits simply paints the entire band for that frame. Now we come to user form activate procedure. User form activate is the entry point when the form shows. The first time this runs, we call make borderless to remove the normal frame. We guard it with a static done variable so that we only do that once per form lifetime. Otherwise, this will keep on running every time the user form activates. Then, if we are not yet initialized, we call init ether to set up the band and stars. I already explained these procedures few minutes ago. After init ether, we figure out where the top of the band is in TWIPS, which is form coordinate system, using me dot inside height and the same ratio. Then we position the frame 1, which we use as a line. We make it visible, stretch it to the full inside width, and place it just above the ether band using frame above ether gap. So visually you get text and controls above the frame and the animated universe just below it. Next we get the device context for this window using getDC. If that fails, we simply exit. And if it succeeds, we set mRunning is equal to true and enter the main animation loop. Inside the animation loop, we call stepped stars to update positions and alpha. We call the build frame to redraw the band plus stars into memory. We also call blit frame to paint it to the window. Once that is done, we then check if the escape key is being passed using getAsync key state. If it is, we stop the loop and unload the form. Finally, we call doEvents to keep the UI responsive and sleep 40 to control the frame rate. 40 milliseconds gives roughly 25 frames per second. This entire animation comes to an end if mRunning is set to false from any place. And when that happens, the loop ends. The remaining event handlers simply stop the loop and clean up. Query close sets the mRunning flag to false, so the loop exits cleanly when the form is closed. Terminate calls release DC if we have a valid handle, so we do not leak resources. The click closes the form when the user clicks anywhere on the form. And the key down simply listens for the escape key and closes the form. So the user can exit in two ways, either click on any area of the form or simply press the escape key. So this is the complete story of the Aether form. Now that we understand the design and the code, let us actually run this form and see the Aether effect in action. To run the form, press F5 on your keyboard. You can also click the small run button on the toolbar. Both do the same thing. So I'll click this button now. And there you go. This is the animated Aether About Form. You can see the soft star field drifting in the background and the stars gently glowing and fading. Everything feels alive, yet the top half remains clean and readable for your app information. Remember that this is not a GIF, not a video, or even an image. Everything you are seeing here is being drawn at runtime using pure VBA and GDI. The motion is real time and it will look the same inside your actual Excel application. If you want to close the form, just press the escape key or click anywhere on the form. This is especially useful when your About form is part of a bigger Excel project. So I'm going to press the escape key, and that completes the Aether form. In the next part, we will move to the Aether About form. Just like we did here, I will walk you through the design first and then explain how the animation code works. Let's jump to that next. Now let's move to the Aether About form. In the Project Explorer on the left, look for the form named FRM About Air. Go ahead, double click on it to open the form. Now you will notice something immediately. The design layout is the same as the Aether form. We have the same idea, text and labels in the top half and the animated area reserved at the bottom. So I'm not going to spend time explaining the UI controls again because that part is already clear from the Aether form. Instead, let us jump straight to the code by double-clicking on an empty area on the form. Alright, now we are in the code window. Let us start from the top. At the very top, you will see two settings. The first one is the height ratio. In this form, it is called sky height ratio. It works exactly like the Aether height ratio. The second setting is the gap used to position frame 1 just above the animated band. Again, same idea as Aether. Next, we have the type section. Here again, you will see rect, bitmap info header, and bitmap info. These are the same structures we used earlier. They are needed because we are going to draw into a pixel array and then push that pixel array to the form using GDI. Now, here is the first new thing. Instead of a star type like Aether, we have a cloud type. This is basically a small definition of what one cloud is. Each cloud needs an X and Y position, so we know where it is on the band. Radius X and radius Y, so we can make it wider than it is tall. Speed X, because clouds move sideways. And alpha, which controls how soft and transparent the cloud looks. Right after the settings and type definitions, we come to the section that looks very familiar, the Windows API declarations. We are not changing anything here from the Aether form because the job is still the same. We need to know where the form is, how big it is, and how to paint on it. So at this point, nothing new is happening here. We are simply setting up the same foundation we used in Aether. Once this is in place, the next thing that we do here is define constants and variables. And that is where the Aether form starts to diverge from Aether. So at this stage, nothing Aether specific has happened yet. This is just same plumbing that allows us to do real-time drawing in a user form. Again, these are familiar. Things like dib RGB colors, src copy, and a count constant, which here is max clouds. So in Aether, you control the number of stars using star count. In Air, you control the number of clouds using max clouds. Now we reach the state variables. This is where it starts to feel connected. You again see these two for form size in pixels, and then these two for the band size. These two are our 2 pixel buffers. BMI describes that pixel buffer, and then we have clouds array, which is the Air version of the stars array. And just like before, we have rest of the variables. Now we move into the helper routines. Dib color is the same helper as before. It packs RGB values into a long so we can store it in the pixel array. Make borderless is also the same idea as before. It removes the caption and border so the form looks like a clean modern window. Now comes the first truly Air part, which is the init Air. This procedure is the setup. It runs once and it prepares everything we need before animation starts. It is almost like the init Aether procedure. So I'm not going to explain each line, but give you a gist. At the start of init Air, we find the form handle and get its size in pixels. Then we calculate sky edge as 40% of the form height. Because this bottom band is what we are animating. Then we allocate our pixel arrays base IMG, which will store the background sky gradient, and frame IMG, which will be used for each animation frame. Then we fill in the BMI header, so stretch DI bits understands the format of our pixel buffer. Now we build the sky background. You will see the top and bottom colors and a loop that fills every pixel row by row. This creates a smooth blue gradient. So at this point, even without clouds, you already have a sky band. After the background is ready, we create the clouds. We redeem the clouds array, and then for each cloud, we randomly assign width and height radii, so each cloud is a different size. An initial exposition, so clouds start at different places. A Y position around the middle of the sky band, so they are not all in one straight line. A horizontal speed, so clouds drift at slightly different rates. And alpha, so some clouds are softer and some slightly stronger. So the output of init air is a ready sky gradient in base IMG and a set of cloud objects ready to be animated. Next is step clouds. This is the movement step. For each cloud, we simply add speed x to its x. That makes it move from left to right, and if it goes off the right edge, we wrap it around to the left again. That creates a never-ending drift. Now comes build frame. This is exactly the same pattern as Aether, but instead of drawing stars, we draw clouds. First, we copy the whole base IMG into frame IMG. That resets the frame to a clean sky background. Then we loop through each cloud and call draw cloud. So the sequence becomes very logical. Update cloud positions in step clouds, rebuild the fresh frame in build frame, and draw clouds onto the fresh frame using draw cloud. Now let's understand draw cloud. This is where the air visual is created. A cloud is basically a soft ellipse. So the first thing this procedure does is calculate a rectangular area around the cloud based on its position and radius. This is just an optimization. Instead of looping through the entire sky range, we only loop through the area where the cloud actually exists. Next, we loop through every pixel inside that rectangle. For each pixel, we check whether it lies inside the ellipse of the cloud. If the pixel is outside the ellipse, we ignore it. If it is inside, we calculate a soft alpha value that fades towards the edge. Now comes the most important part. We do not draw a solid color. Instead, we first read the background color that already exists in the frame. Then we blend that background color towards white using the alpha value. The blending is what makes the cloud look soft and smoky instead of harsh. Finally, we write the blended color back into the frame buffer. So in simple terms, in the Aether form, the drawing function was draw star. In the air form, the drawing function is draw cloud. The animation loop is the same. Only the drawing logic changes, and that is what creates a completely different visual. Next is billet frame, which is the final display step. This again matches Aether exactly. It calculates where the bottom band starts, and then one call to stretch DI bits paints the whole band onto the form window. Now let us quickly look at user form activate. If this looks familiar, that is because it is the same structure as the Aether form. We are not introducing any new logic here. Just like in Aether, we first make the form borderless, then we initialize the air animation if it has not already been initialized. We position the labels and frame 1 above the 50% mark, keeping the animated area free. We get the form's device context so we can draw on it, and then we center the animation loop. Inside the loop, the pattern is exactly the same. We update the animation state, build the frame, and billet it to the form. The only difference is what is being animated. In Aether, the loop was calling step stars and draw star. In air, the loop calls step clouds and draw cloud. So once you understand user form activate in Aether, you automatically understand it here as well. That is why I'm not re-explaining this part. Let's now run it. Press F5. Now you can see the sky band at the bottom and the clouds drifting gently across it. The top part stays clean and readable, and the bottom part feels alive. This is exactly the kind of subtle animation that makes an Excel tool feel polished and intentional, not distracting. Let's close it. You can do that by pressing the escape key. And with that, we conclude the Aether About form. Next, we will do the same thing for the FRM about Earth. The structure will still be familiar, and I will again focus only on what is new in that form. Let's close this toolbox. Double click on the FRM about Earth. The layout is the same pattern as the previous forms, so we will not spend time on the design again. Now double click on the form to open the code window. At the very top, there are two settings you should notice. The first one controls how much vertical space the earth animation takes at the bottom of the form. So just like ether and air, only the lower 40% of the form is animated. The second setting simply adds a tiny gap between the animated area and the content above it, so things do not visually touch. After this, a large portion of the code is exactly the same structure we have already seen in ether and air. We have the same Windows API declarations, the same bitmap setup, the same pixel buffers, and the same animation loop. So instead of repeating all of that, let us jump straight to the part that actually makes Earth look like Earth. Scroll down to the procedure Draw Hill layer, which is this. This is the heart of the Earth form. What we are doing here is not drawing waves and not drawing perfect mountains. Instead, we are building natural rolling land using control points. We first generate a small number of random vertical control points across the width of the form. These points decide how high or low the land will be at different positions. Then, instead of connecting those points with sharp lines, we smoothly interpolate between them using the helper smooth step. That smoothing is what removes harsh edges and makes the land feel organic. Once we know where the top of the hill is for each X position, we simply fill everything below that line with a solid color. That is how each hill layer is created. If you scroll a little bit further down, you will see where this is used. We are deliberately drawing only two hill layers, both near the bottom of the band. Everything above stays flat and blue, so it reads as sky and keeps the form clean. Now let's talk about briefly about motion. The land itself does not regenerate every frame. Instead, in step earth, which is this particular procedure, we apply a very gentle horizontal shift using a sine wave. That tiny left-right movement is enough to make the scene feel alive without turning hills into waves. Finally, we add clouds. This is where we draw the clouds. This is very similar to the cloud logic you saw in the air form. Each cloud is made from a few overlapping soft ellipses, blended gently into the background. They move slowly across the sky, completely independent of the hills below. So let's run it and let's see it in action. I'm going to press F5. You can see the bottom two layers behaving like rolling land, the sky staying calm above, and the clouds drifting slowly across the scene. Nothing flashy, nothing distracting, just subtle motion that makes the about form feel finished and professional. This is the kind of animation you can leave running without it ever pulling attention away from the actual content of your app. Let's close it by pressing escape. So this was the earth form. Next, we will move on to the fire form. Double click on the FRM about fire. Again, the design is the same. So double click on the form to view the code. Let's go right at the top. At the very top, there are the two settings that you will see again. This controls how much vertical space the fire animation occupies at the bottom of the form. Here it is slightly more than the others because flames need a bit more vertical room to look natural. The second setting, as usual, simply keeps a small visual gap between the animated fire band and the content above it. After this, most of the code follows the exact same structure we have already seen. We have the same Windows API declarations, the same constants, same borderless procedure, same initial procedure for fire. So I'm not going to explain that. So instead of repeating all of that, let us jump straight to the core of the fire animation, which is do fire step. This is where the fire simulation actually happens. The idea here is very simple. We maintain a 2D array called fire, where each cell represents the intensity of fire at that pixel. Higher values means hotter fire, lower values mean cooler or no fire. The very first loop inside this procedure generates new fire at the bottom row. This bottom row acts as the fuel source. Every frame, we randomly inject high or medium intensity values here so the fire keeps burning. Then comes the important part. The second loop moves upward from the bottom towards the top. For each pixel, we'll look at a nearby pixel below it, reduce its intensity slightly, and move it upward. This is what creates the illusion of flames rising. The small random left-right shift and the random decay are what stops the fire from looking uniform or mechanical. Once the intensity values are updated, we move to the next procedure, build frame. Here we convert intensity values into actual colors. Each intensity level maps to a color from the colors array, which was built earlier in init fire. That color ramp goes from dark red to orange to yellow and finally to white at the hottest points. So build frame simply translates fire intensity into pixels. After that, the frame is pushed to the screen using stretch DI bits, exactly like in the other forms. So let's go ahead, let's run it. You can see the flames constantly forming at the bottom, rising upward, flickering, and fading naturally. There is no looping animation here. The fire is procedural, which means every frame is slightly different. Again, nothing distracting, just control movement that gives the about form a strong visual identity. This form is my favorite. Okay, let's go ahead, let's close it by pressing the escape key. Well, that concludes the file form. Next, we will do the same thing for the water form. Double click on FRM about water. The design is the same. So let's go ahead and double click on the form to view the code. Most of the code is the same. Let us directly scroll down to init water engine, which is this procedure. This runs once when the form starts. First, we store the form caption, store the band dimensions, and allocate memory for our arrays. Then we build the base gradient background. You see the loop? So we create a smooth water-like blue gradient and we add a little random noise so it does not look like a flat plastic surface. Then we set up the bitmap header. This is the part that makes stretch DI bits work. Now let's scroll down to start water animation. This is our animation loop. Every frame we calculate the wave field in step water, then we render it in render water. Now let's focus on step water because this is where ripples are generated. At the top, we define ripple source locations. Each one represents a drop hitting the water at a different place. Then we move time forward. This time value is what makes the rings expand and move instead of staying frozen. And now we compute the ripple parameters. Wave speed controls how fast the ring expands. Sigma controls how thick the ring is. Radial damp controls how fast it fades as it travels outward. Then we stagger the sources so that they do not all start together. So the ripples start one after another instead of all at once. Now comes the main loop where each ripple gets a wave value. This is the heart of it. For each ripple source, we calculate distance r, compare it with the current ring radius r0, and create a ring using a Gaussian band. That is what makes the ripple look like an expanding circle rather than a full sine wave across the whole surface. Finally, we add a tiny irregularity so it does not look like a perfect target pattern. And we clamp it. Now let us move to render water. This is where we turn those wave values into illusion of moving water. Inside the loop, we compute how steep the surface is by looking at neighbors. Then we turn that into a pixel offset. and we sample from a shifted position in the base gradient. That is the distortion trick. It makes the water look like it is refracting and bending. Finally, the frame is pushed to the form using stretch DI bits. Okay, time to run it. I'm going to press F5. And there you go. You can see ripples forming continuously at different points, spreading outward, overlapping, and fading away naturally. The top part stays clean and readable, while the bottom part adds life without distracting the user. Your eyes are drawn to it, but only just enough to notice that something special is happening. After the fire form, this is my favorite form. Okay, let's press escape to unload the form. And that completes the water about form. As a special bonus, I have added one more about form. Now let us look at that bonus about form. Double click on FRM about random. The design is the same. So let's double click and view the code. This form is a little different from the earlier ones because we are not simulating a specific element here. This is more like a random animated pattern that still looks clean and professional behind your about text. Look at the state variables. The naming is different here because we are treating this as a neutral animation band. So instead of building a background image and distorting it, this form uses a single buffer called pixel buff. That means we are generating the pixels directly every frame. Now look at this procedure. This is where we initialize the animation engine. First, we find the form window and read its size. Then we calculate the band size using the ratio, and then we allocate the pixel buffer. Right after that, we set up the bitmap header. So now Windows know that pixel buff is a 32-bit top-down image. Now comes the most important part of this form, which is build frame, this particular procedure. This is where the visual pattern is created. We loop through each pixel in the band. For each pixel, we calculate two values, U and V. These are just the horizontal and vertical positions of that pixel, converted into a 0 to 1 range. Now we build a moving pattern by mixing three sine components. Think of these as three layers of motion. One is medium frequency, one is slow and broad, and one is tighter. When they blend together, the result stops looking repetitive. Then we mix them. And from that mix, we calculate an overall brightness value called intensity. Then we convert that intensity into RGB values so the band stays in a nice blue-green range. But it moves because the intensity keeps changing. We also add a slight highlight effect when the mix crosses a threshold. So some areas look slightly more shiny, which makes the animation feel more alive. And finally, we store the pixel in the buffer and we update the tick counter so the pattern keeps moving. Now look at belit frame. This is the part that actually draws the band on the form. We calculate where the band should start and then push our pixel buffer onto the form. So build frame creates the pixels and belit frame paints them. Moving on to user form activate. This controls the full flow. You will see the familiar steps. Make it borderless, initialize the band, position the frame above the band, and then the animation loop. So on every cycle, we build a fresh pattern, paint it, and wait a little so it does not run too fast. Okay, time to test it. I'm going to press F5. You can see the bottom band generating a smooth animated design in real time. The top part stays clean and readable, while the bottom adds subtle motion that makes the about form feel modern and polished. And because it is procedural, it is not a fixed image sitting in an image control. It is being created live at runtime using GDI. And with that, it completes the bonus about form. I'm going to press the escape key now. And with that, we come to the end of this video. We took the humble about form and turned it into something more. 5 fully animated designs inspired by the elements of nature. plus a bonus procedural design, all created at runtime using pure VBA and GDI, no images and no GIFs. You can now use these ready to plug and play about forms instead of those boring about forms to make your Excel application feel more professional and polished. If you have any questions regarding today's video, feel free to leave a comment in the comment section below. Or as usual, you can also email me on support@tamexcel.com. I also have a Facebook group. The link is mentioned in the description below. Feel free to leave any kind of comments, any questions in that group. But if you're asking any questions, ensure you include some kind of screenshots. It'll be much more easier to answer your query. And hey, if this tutorial saved you time or taught you something valuable, you can show a little bit of extra love by clicking on the super thanks button below the video. It not only supports the channel but also keeps these tutorials coming. If you found this video helpful, hit like and smash that subscribe button so you do not miss the next one. Thanks for watching, and remember, it's the small details that make Excel feel like a real software.